Okay, let's talk about something that sounds like it's straight out of science fiction, but it's happening right now. What if an AI could write the code for computers that operate on the absolute edge of physics? Well, we're diving into exactly that today. A new AI from Penn State that is learning how to program quantum computers. This is a big deal.
So, just imagine for a second an AI that can cook up the incredibly complex recipes needed to run a quantum computer. And I don't mean just, copying and pasting old recipes. I'm talking about generating completely new, totally functional designs, all from scratch.
But let's take it a step further. What if that AI was perfect? I mean, what if every single recipe it wrote was flawless? Every single one following the bizarre rules of quantum mechanics, ready to run, every single time. That is the incredible, almost unbelievable promise behind the new system we're going to break down.
All right, so let's get into it. Let's meet the AI that's actually making these quantum recipes. And believe me, this isn't just your everyday AI. It's a highly specialized system built to take on one of the toughest challenges in all of modern computing.
The system has a pretty cool name, Q-Fusion. At its core, it's an AI that's designed to automatically generate these things called quantum circuits. But the really amazing part, the thing that makes it so different, is how it does it. It uses a new approach called a diffusion model, and that's a whole new way of looking at this problem. So what in the world is a quantum circuit anyway? Well, the easiest way to think about it is like that recipe we mentioned, but a really, really precise one. It's the step-by-step instructions for a quantum computer. And if you miss a single step, or use even a slightly wrong ingredient, the whole thing just fails. Perfection isn't just a goal, it's the only option.
Okay, so you might be wondering, why do we even need an AI for this? Can't people just write the code? Well, it turns out that programming these things by hand has become a massive bottleneck. It's actually holding back the entire field of quantum computing.
Yeah, trying to design these quantum recipes manually is, well, it's just incredibly hard. First, you need some serious hard-to-find expertise. It's super slow and labor-intensive. And on top of all that, it is shockingly easy for even the smartest person to make one tiny little error that completely wrecks the whole program. And as these computers get bigger and more complex, this old-school manual approach, it just doesn't work. It can't scale. And this is where Q-Fusion's strategy gets really, really clever. Instead of trying to make the AI think like a human programmer, which is what you might expect, it learned in a totally different way. It basically learns by cleaning up a mess.
So here's how that works. It's a pretty wild idea. The AI starts with a perfect, clean quantum circuit. Then, the system intentionally adds noise to it. It just completely scrambles the structure. The AI's only job, its entire training, is to figure out how to perfectly reverse that process, how to unscramble that mess and get it back to the original. Once it becomes an expert at cleaning things up, you can give it pure random noise, and it will denoise it into a brand new, perfectly valid circuit. It's amazing.
And honestly, this is a huge leap forward. You see, older AI methods tried to do things like treat circuits like they were sentences in a language, using models kind of like ChatGPT. But that totally misses the point. A quantum circuit isn't just a string of words. It's a deeply complex, interconnected structure. Q-Fusion's method, this diffusion approach, actually learns the deep structural rules of what makes a circuit work, allowing it to build them correctly from the ground up.
Okay, so the method is fascinating for sure, but the big question is, did it actually work? Well, this is where the results go from interesting to absolutely groundbreaking.
100%. That's the number. Across thousands of different tests, every single quantum circuit that Q-Fusion generated was valid. It never created a broken or impossible recipe. Not once. Every single one it produced followed the laws of quantum physics and could, at least in theory, be run on actual hardware.
But hold on, were they just copies? Was it just spitting out circuits it had already seen in training? Nope. For the smaller test circuits, not only was the validity a perfect 100%, but get this, over 40% of them were functionally unique. It wasn't just memorizing, it was actually creating.
So the next logical question is, how does it handle more complex stuff? Well, even when they scaled up the challenge to a much larger 5-qubit circuit, that perfect validity, it stayed at 100%. That is just remarkable. But this is also where we see the next big hurdles. The rates of uniqueness, creating new stuff, and something called meaningfulness, which is basically how useful the circuit is, both of those dropped. And that tells us that creating genuinely innovative and useful circuits gets way, way harder as things get more complex.
So what does this all mean for the big picture? Let's zoom out and talk about the future that this kind of technology could unlock.
Now, to be clear, the researchers are very upfront about the limitations. I mean, just checking if a huge, complex circuit even works is a massive computational challenge in itself. The AI also doesn't have that deeper quantum intuition yet, like it can't spot a redundant step that a human expert would probably simplify right away. Plus, right now, it's all trained on synthetic data, not real-world problems. So yeah, these are definitely the next big mountains to climb.
But even with those challenges, the outlook is incredibly bright. The Penn State researchers who created this are convinced that these diffusion models have significant potential to improve what's called quantum architecture search solutions. And that's basically a fancy term for the entire field of automatically designing quantum circuits.
When you boil it all down, Q-fusion really represents a fundamental shift. It points toward a future where AI isn't just a tool, but more like a creative partner for scientists. A partner that can accelerate discovery by automating one of the most tedious, mind-numbingly difficult parts of quantum computing.
And so all of this research leaves us with a really profound question, one that really makes you think. As these AI tools get more and more powerful, you have to wonder, will the next world-changing quantum breakthrough be designed not by a human, but by an AI?